Daria from the Church School Lab.
Hi, I'm Daria, and today I'll be talking to you about trichloroethylene contamination in North Adams. My thesis this year took a twofold approach to understanding the extent of trichloroethylene contamination. The first part of this thesis looked at developing a model to understand the contaminated plume, and the second part of this thesis looked at quantifying contamination in soil samples. So to begin, what exactly is trichloroethylene? So from now on, I'll refer to trichloroethylene as TCE. It is this chemical over here. We see it has two carbons that are double bonded with 3 chlorine atoms attached and a hydrogen. Now, this structure makes TCE very stable and persistent. Therefore, it was very appealing for industrial uses. In the 1950s, it was widely used as a degreasing agent due to its high efficiency in dissolving nonpolar substances. TCE is also a volatile organic compound, or a VOC, meaning that it readily escapes into the gaseous phase. TCE now is a classified carcinogen and is therefore heavily regulated and banned by the EPA. Due to exposure to it can cause adverse health outcomes. Now, my study looked at North Adams as a case study. So can I have a show of hands of how many of you have been to Mass Mocha? Great, so pretty much everyone. I, if I'm being honest, have not been there yet. Hopefully soon. Exactly. However, where Mass Mocha now was once home to Sprague Electric. Sprague Electric was a manufacturer of capacitors and electronic components. However, in 1985, they ultimately closed their doors in North Adams. Upon leaving North Adams, they had waste that they needed to dispose of. This led to them burying over 1,055-gallon drums of byproduct waste at a Fairgrounds Avenue landfill. Now, this waste equated to over 42,000 pounds of liquid trichloroethylene being disposed of underground. And as I mentioned earlier, TCE is a volatile organic compound. So by 1997, there were reports that the TCE had begun to leach into residential homes. Now, to better understand where we're located, this over here is the Fairgrounds Avenue landfill. We see the Hoosick River flowing here, and the stars depict two sites of interest, Alton Place and Avon Street, which I will talk more about later. But these are sites that historically have shown higher levels of TCE contamination that have been impacting residents. Now, for another scope. This is what the Fairgrounds plume looked like in 2015, and here we see Mass Mocha, the Hoosick River, Route 2, where Sprague Electric was, and the other Sprague Electric buildings, for context. Now, how exactly did the TCE get into people's homes? So the TCE had leaked out of the barrels and entered the groundwater. As a volatile organic compound, it volatilized out of the groundwater, upwards through the soil, and then entered residential homes through things such as gaps and cracks in the foundation of the residential houses. So my thesis looked at better understanding the current extent of the TCE plume. We have historical data from 1990 to 2004, and the plume was last studied in 2019. Clearly, there are huge gaps in our understanding of where the TCE plume is now and the time in between. So my thesis looked at developing a model to understand the current extent of the TCE plume, as well as determining the current concentrations of TCE in North Adams through soil sampling. So the first approach looked at modeling the current state of the plume. Through this, we developed all of these models, which I know looks overwhelming, and trust me, it was. And as much as I would love to talk to you about all of these models, I'll spare you, and I'll just highlight a few important ones. But all these models ultimately give important information as to how the TCE plume may have traveled. So to begin, our model was developed using historical groundwater data. Primarily, we looked at monitoring well 3, which is the site of the Fairgrounds Avenue landfill. Over here, we see the years since the monitoring well 3 began, and on the y-axis, we see the TCE in micrograms per liter. Ultimately, we have an initial increased amount of TCE concentrations, followed by a decrease with fluctuations in between. Now, our model also accounted for the physical properties of TCE, which first included vapor pressure. We see as the temperature in Kelvin increases, so does the vapor pressure, meaning that as temperature increases, TCE volatilizes out. This can further be explained by Henry's law, which we ultimately found the unitless Henry's law, or KIAW, which correlates pressure, vapor pressure, and concentration. We ultimately see as temperature increases, there's a positive linear relationship between temperature and our KIAW. we also use this governing equation, which showcases the advection dispersion reaction with regards to retardation, and we use these parameters to help develop our model. From this, we began running our model, and we got these first preliminary results. Now, these results showcase monitoring wells over the course of the TCE plume. We see over here monitoring well 5, which is located 152 meters from the plume, from the Fairgrounds Avenue landfill, and then monitoring well 31B located 1,300 meters from the Fairgrounds Avenue landfill. On the x-axis, we see the years since the monitoring well 3 began, and on the y-axis, we see the TCE concentration in the log scale. The solid line depicts our model projections, and the dots showcase the raw historical data. Overall, we see a similar trend amongst all the models, with an initial spike correlating to the start of the TCE plume, followed by a gradual decrease. However, it's notable that all of these models, but especially those further downstream of the landfill, are under-predicting the TCE concentrations. Now, we also have a nice video that showcases how the plume travels over time. To orient ourselves, monitoring well 3 over here is the landfill, and then monitoring well 15 is about where Avon Street and Alton Place are. So we're going down gradient and westward. We see that as the plume travels, the TCE concentrations rise down gradient, and then this is then followed by a gradual decrease in TCE concentrations over time. However, it's notable that the center of the plume remains at monitoring well 3, where concentrations remain the highest. Now, this video showcases the interpolated historical groundwater data. We see a similar trend with, as the plume travels down gradient, the TCE concentrations increase. However, interestingly, with the historical data, we see that the center of the plume migrates to monitoring well 15 and not the landfill. Now, this isn't in line with our original model projections. So, the key takeaways that we gain from this are that our model ultimately underpredicts TCE concentrations and projects that the TCE plume will flush out. This also showcases that the historical data differs from our model projections. So we asked ourselves the question as to what's impacting our model's limitations. So this project next moved to analyzing soil samples to better understand the current extent of the TCE plume. So we move forward with trying to quantify the levels of trichloroethylene in North Adams. And this was done through collecting a series of soil samples. We collected 11 soil samples at sites of interest. These included the Fairgrounds Avenue landfill, and then Avon Street and Alton Place. We then used a solid phase microextraction, or a SPIMI, in tandem with the GCMS in order to quantify concentrations. So what exactly is a SPIMI? We had soil samples in vials that we heated up to let TCE volatilize into the headspace. We then used a SPIMI, which has a needle and a fiber. We pierced the needle through and injected the fiber and let the TCE sorb to the fiber. We then retracted and injected this into a GC inlet for analysis. Then external calibration methods were used to quantify TCE concentrations. This was done by creating a TCE standard curve, and then we back calculated to find the TCE concentrations in our soil samples. Ultimately, these were our results. And we found that concentrations of TCE at Avon Street and Alton Place tended to be higher than those at the landfill. However, there were limitations, which I will talk more about later. And we ultimately found that the results fall below the EPA guidelines for the carcinogenic total soil limit. However, we were still missing something. Our model projects that the center of the plume should remain at the landfill, thus the concentrations of TCE should remain highest at the landfill. But our data showcases that Avon Street and Alton Place are experiencing higher levels of TCE concentrations. Upon further investigation, we found that there was a flood chute built in the 1950s that impacts the natural flow of the TCE plume, which could potentially explain the accumulation of TCE at Avon Street and Alton Place. Now, what exactly is a flood chute? Because I didn't know, but it's this sort of concrete wall that directs the flow of water. So our next steps looked at recalibrating our original model to account for this flood wall to better understand how it impacts our TCE plume. So through our model recalibration, we got a series of new models, one of which I will talk about now, This is modeling rule 29, and we see that ultimately the same trend is depicted, where the initial spike followed by a gradual decrease. However, in accounting for the flood chute, the model is more accurately able to project the TCE concentrations. Now, this video showcases similar trends as our previous videos. However, we ultimately see that through time, the TCE concentrations remain higher, and this could be explained by the presence of the flood chute, which is impacting the natural flow of the TCE plume. Ultimately, this thesis found that the TCE concentrations in North Adams are below the EPA guidelines, and we also developed a model that is able to project the current extent of the TCE plume. However, this research was greatly limited in what we could do. Therefore, future research should look at collecting more soil samples to gain a better understanding of how the TCE plume has traveled and what the current state of it is now. Furthermore, it's very vital that we test the groundwater. This thesis had originally begun in wanting to test the groundwater. However, we weren't able to gain access to the groundwater, at least through legal ways. So future research to look at finding ways to gain that access and tracking the groundwater, as it's important to being able to fully understand how the TCE plume has traveled, and it's also more optimal in comparing it to the EPA standards. Furthermore, we spent a lot of, especially this past semester, optimizing our calibration methodology, and running more samples under this new methodology is essential. And I would like to thank Anthony for all of your help and all of the pep talks. Thank you, Jose, for all of your support. Thank you, Dee, for being such a great buddy in this, and I would highly recommend going to her thesis talk next week. Thank you, Dr. Brown, Jay, everyone in Anthony's lab, especially Sam. Thank you to my friends and my family, especially my siblings, for being my biggest cheerleaders and my biggest